All right, for question A, what is your walking rate in meters per second? We found this out when we were outside running. For example, I ran 50 meters in 14.25 seconds. If I want to get that down to a unit rate, I simply divide my meters by seconds. Mine came out to be about 3.5 meters per second. If I want to know how long it would take to run 500 meters, I simply take my 500 meters and divide it by my rate of 3.5 meters per second, which got me to about 142.9 seconds. If I want to know how far I will run in 30 seconds, again, I take my rate, 3.5 meters per second, and I multiply it by my time. The first time it asks is for 30 seconds. I multiply this by 30 seconds, which got me about 105 meters. I can do the same thing for 10 minutes. However, because my rate is in seconds, I need to convert 10 minutes into seconds, which I know is 600 seconds because there is 60 seconds in 1 minute, and 10 times 60 is 600. Now that I converted my 10 minutes into seconds, I did my math and I got about 2,100 meters in 10 minutes. For 1 hour, I can do the same thing. I take my rate, 3.5 meters per second. I have to convert my 1 hour into seconds, which is 3,600 seconds in an hour. Multiply that out. This answer came out to be about 12,600 meters in 1 hour. Question 3 is asking you to put into words the relationship between the distance you travel and the amount of time that you are walking. So if I were going to do this for me, I would write something like, for every 1 second I am jogging, I will travel 3.5 meters. Question 4 wants you to put your sentence from question 3 into an equation form. For me, this would look like my distance equals my rate of 3.5 and multiplying that by the time. In question 5, it wants you to use that equation that you just made to predict the distance you would walk in 45 seconds. So I would write my equation D equals 3.5 times T, and I would replace that T with 45 seconds. And when I multiply that out, I get D equals 157.5 meters. For question A1, we needed to use the information that was found on the previous page for each of the students, where it said Elena is walking 1 meter per second, Gilberto is walking 2 meters per second, and Leanne is walking 2.5 meters per second. For this question, I created a table just on pages and I inserted it here for you to see. The question is, how does the walking rate affect the data? If you notice on this table, Elena's data goes up by 1 for each second that she is walking. Gilberto's data goes up by 2 meters for every second that he is walking, and Leanne's data goes up by 2.5 meters for every 1 second that she is walking. If we look back at that table that was found on the previous page, we notice that for each student, the data per second is increasing by that student's walking rate. Question 2 asks you to graph the information that you have in your table onto the same coordinate axis. I did that here, giving each student their own color. The question asks, how does the walking rate affect the graph? If you look at Elena's graph, her line is the blue line here, you can see that her line of data does not have a very high slope. If you look at Gilberto's data, whose walking rate was 2 meters per second, you can see that his line begins to have a steeper slope. And Leanne's even steeper as her walking rate was 2.5 meters per second. Question 3 asks us to write an equation that gives the relationship between the time and the distance for each student. We know that Elena's walking rate was 1 meter per second. Similarly to what I did with my data on the previous page, I would put that into the equation distance equals rate, which for Elena is 1 meter per second, multiplied by the time. I would do the same thing with Gilberto, and his rate was 2 meters per second. Putting that into the same equation, I would get distance equals 2 multiplied by time. For Leanne, her rate was 2.5 meters per second. If I put that rate into the equation, I get distance equals 2.5 multiplied by time. Question 1 in part B is asking, if time is increased by 1 second, how does the distance change for each student? If we look at Elena, for each 1 second that the time goes up, her distance also goes up by 1 meter. For Gilberto, when that time increases by 1 second, his distance increases by 2 meters. With Leanne, when the time goes up by 1 second, her distance increases by 2.5 meters. This happens every single time for each student. In the graph, the same thing occurs. When the time goes up by 1 second, Elena's distance goes up by 1 meter, Gilberto's distance goes up by 2 meters, and Leanne's distance goes up by 2.5 meters. Question 2 asks, when the time is increased by 5 seconds, how much does the distance change for each student, and how is that represented in the table and in the graph? In the table, when time goes up by 5 seconds, Elena's distance goes up by 5 meters. Gilberto's distance goes up by 10 meters, and Leanne's distance goes up by 12.5 meters. This happens again from 5 to 10 seconds, where Elena's distance goes up by 5 meters, Gilberto's distance goes up by 10 meters, and Leanne's distance goes up by 12.5 meters. The same thing can be seen in the graph. When time goes up by 5 seconds, Elena's distance goes up by 5 meters, Gilberto's distance goes up by 10 meters, and Leanne's distance goes up by 12.5 meters. The same thing can be seen when we reach 10 seconds. For Elena, she goes from 5 meters to 10 meters. Gilberto goes from 10 meters to 20 meters, and Leanne goes from 12.5 meters to 25 meters.